Hi, I'm Chris Ferdinandi, and this is the Lean Web, some ideas I have around building a simpler, faster World Wide Web. This is the talk that I gave to the Boston CSS meetup in January of 2019. And based on some questions that I got there, I'll be making some changes to this talk, but I thought it was better to get something out there now rather than wait until it's perfect. So let's dig in. So, in my opinion, the web today is a bloated, over-engineered mess, and I believe that many of our modern best practices are actually making the web worse. What I want to explore today are some ideas on how to fix it, and maybe look at a new set of best practices to replace what we do today. Hi, I'm Chris Ferdinandi, and you can find me online at gomakethings.com, which is a lot easier than trying to spell out Ferdinandi. I'm known on the web as the Vanilla.js guy. I didn't come up with the term, but I spend a lot of time evangelizing the use of native JavaScript and browser APIs instead of libraries and frameworks. I live in ruralish Massachusetts near farms, horses and fruit mostly, and I actually started my career in human resources. About 6 or 7 years ago, I taught myself to code and then transitioned into web development. It was an awesome career move, and I highly recommend it. I'm self-taught, and I started with HTML, CSS, and WordPress. Then I moved into jQuery, which was at the time the way to use JavaScript on the web. Some frameworks existed. I think Backbone was a thing back then, but they weren't really popular. It's not like today where frameworks are everywhere. They were just kind of these things that were starting to pop up. And the reason I made this transition was because honestly, just knowing HTML and CSS, I was finding it difficult to make that career jump. People were looking for JavaScript experience, and I didn't have any. I wanted to understand more about how jQuery worked under the hood, and if I'm being honest, I wanted to feel more like a quote-unquote real developer. So I started learning vanilla JavaScript. At the time, browsers were finally standardizing features and implementations, so cross-browser compatibility was a lot easier than it had been in the past. CSS3 and HTML5 were out, JavaScript's ES5 was out, and pulled in a lot of features from jQuery. In retrospect, it feels like it was the perfect time to have tried to learn this stuff. It was this awesome sweet spot where powerful native features and ease of use were overlapping. And I look at the state of things today, and I feel like I wouldn't have been able to teach myself or make that jump into web development if I tried to do it today using the norms and best practices that we use to build things for the web right now. I want to help other people feel like they can do what I did. They can make that career jump. They can teach themselves how to code. So each weekday, I send out a short email with code snippets, tools, techniques, and random awesomeness from around the web. And you can find that over at gomakethings.com if you're interested. I also write short guides and create video courses on vanilla JavaScript over at vanillajsguides.com, and recently launched a project-based training program called the Vanilla.js Academy, which you can find at vanillajsacademy.com. I've gotten to teach students at some really amazing companies like Chobani and 10up and the Boston Globe. My code has been used by organizations like Harvard Business School, and probably the highlight of my career, Apple used one of my open source Vanilla.js plugins on their Swift website. This was a couple of years ago. They're still using it there today. It was just kind of mind-blowing to me. Everyone who subscribes to my newsletter gets an email from me that asks, what's your biggest challenge in web development? And I get back a lot of different responses, but the one I get back more than anything else is some variation of this. My biggest challenge is keeping up. And I'd say this probably makes up about 50, maybe 60% of the responses I get back. It's at least half of them. It's pretty intense. The good news is there's a push towards simplicity on the web happening. Earlier last year, Thomas Fuchs tweeted, "Is there a conference for web developers that specifically caters to lean web? Don't use JS if not necessary, etc." He's used the term the lean web a few times since then, and as far as I know, he's the one who coined the term. I really like it, and it's what I'm going to be talking to you about today. I just feel like it really accurately describes kind of my ethos for building things for the web and what I'm hoping to accomplish with this talk. So here's the agenda. We've already had our intro. We're going to spend about half of the time talking about some problems that I see with the way that we build things for the web. And because only talking about problems is a really terrible way to do a talk, I'm also going to spend the second half talking about some ideas that I have for fixes and how we can do things differently. And then at the end, I'll wrap things up and just kind of summarize everything that we talked about. With that in mind, let's dig right into some of the things that I see as problems. So I mentioned that I think the web is a bloated, over-engineered mess. But how did we get here? I think it's important to maybe look back at how we ended up in this predicament, and maybe think about how we can undo it. I think that in an attempt to make our profession, the front end specifically, seem more mature and professional, we started doing more tools, more buzzwords, more features. Did I mention more tools? Like, we have a real addiction to tools in this industry. It's kind of our biggest vice. We love front-end tooling. You could argue that this is just the result of a maturing industry, that bigger projects mean bigger problems and more complex solutions. But if that were the case, I feel like we would see more stability and standardization. And instead, what we're seeing is more fragility, more fragmentation, and often a repeating of past mistakes. Let's take a quick look at the history of the front end and visit the age of the webmaster to better understand why we're here. Historically, the back end has always had more cred. It's where the, quote, serious business by, quote, real developers happened. The front end was kind of a plaything. It was for fan sites on GeoCities and random musings on LiveJournal. It was under construction banners in the Blink element. And, things like Jesse's skiing page or, LeetSpeak and every other letter uppercased and this really crazy clip art kind of graphics animation stuff. Just really, really experimental Wild West fun kind of stuff. Doom level design fan sites. Now the web is a platform where serious work happens. It runs full-on applications people can use to create presentations and spreadsheets, edit photos and videos, and have real-time conversations with people halfway around the world in video. It's an amazing piece of technology. I can remember my mom back in the AOL era saying she didn't really understand why anybody would ever use the web or why it even exists, and now it's where she does a majority of her shopping. And because of this platform maturity and our desire to be taken seriously, there's been this push to apply back-end best practices to the front end. But the back end is not the same as the front end. In the back end, you have all this control. You control the operating system that your code runs on and when it runs. You control the storage and the RAM and the bandwidth that's available. There's this predictability there. In the front end, you have no control. What we build is accessed by devices of varying capability, by users of varying experience and technical skills, on networks of varying strength and reliability. We keep throwing more JavaScript at things in an attempt to force the control we get on the back end onto the front end. But that's not how the front end works. Alex Russell sums up pretty nicely how we got here in his post, The Developer Experience Bait and Switch. He writes, here's a strongman composite from several recent conversations. Quote, these tools let us move faster. Because we can iterate faster, we're delivering better experiences. But instead of improving the user experience, this creates a bit of a circular problem. We keep throwing more JavaScript at things, and then because we've added so much bloat to our sites with all of this needless JavaScript complexity, we write more JavaScript to introduce more complexity to manage it all and make our code more performant. For example, we've moved our whole stack to JavaScript. React and Vue handle all of the HTML rendering. We've got CSS and JavaScript for the CSS. We're sending megabytes of JavaScript down the pipe. So let's write some more JavaScript to split out our scripts and figure out what we need and only load that. We're going to do some code splitting. Now our entire site is a single HTML file that loads content with JavaScript. So now we've broken that native routing and forward and back button stuff that the browser just gives you out of the box. So we need to recreate all of that with JavaScript. And since all of this stuff is hard to do right and is, introduces a lot of potential for complexity and bugs and things like that, we're going to use some big plugins and a ton of NPM packages to handle all of this for us. So just tools all the things. The argument in favor of all these things is that this tooling removes bugs. It introduces structure, and it helps eliminate errors that might be introduced by junior developers. And to an extent, that's true. But These solutions also introduce their own problems, and I believe there's another way to achieve those same goals without the added complexity and bloat of more JavaScript tooling and the ultimate gatekeeping that results from it. It's 2019. We're walking around with these amazing computers in our pockets that are more powerful than the desktop computers we used in the 90s. If you're watching this and you weren't around then, I remember upgrading my desktop to 16 megabytes of RAM. The latest low-end iPhone has almost 200 times that much RAM in it. There's a massive global network of fiber optic cables that can send data around the world in seconds. We have the technology to make the fastest, most reliable websites and web apps ever. But instead, we're stuck with a fragile, unevenly distributed web that's really fast for some people and terribly slow for others. We run into things like the white screen of death. Maybe you've seen this, where the HTML that the server sends is nothing but an empty div, and the real markup, quote unquote, is rendered entirely with JavaScript. But that file failed to load for some reason, or just hasn't loaded yet. Maybe it's taking a long time, and so you get this empty white screen. Or the content loaded, but the hamburger menu on the page requires JavaScript, and that didn't load. So you can't leave the home page. There's no way to get anywhere else on the app or the site. And yeah, it's 2019. JavaScript is an integral part of how the web works. Most people don't disable it, but CDNs fail. Firewalls and ad blockers get overly aggressive with what they block. I used to work at a company that, for security reasons, had a JavaScript whitelist. So if your file wasn't served from a trusted source, it just got blocked, period. And any site that wasn't part of that whitelist, if it had a JavaScript dependency, it's not working. The absurdly large JavaScript files that we send time out on slow connections. This is even more pronounced with the increased use of mobile computing. And people browsing on mobile devices while commuting go through tunnels and lose the internet. And poof, your whole site implodes on itself. It's a horribly frustrating way to browse the web. Back in 2013, gov.uk did some research to determine how many of their visitors weren't getting their JavaScript enhancements, and they found that 1 in every 93 users weren't getting the JS. But they also found that of those users, 81% of them had JavaScript enabled. The JS enhancements were failing for all of the other reasons that we just talked about. Now, granted, this was about 6 years ago now, so I usually get asked, well, that was a while ago. Do we have any current data on that? I've gone looking. It's kind of hard to find. I did find one site that shared kind of similar numbers to what they had that seemed to be updated a little bit more recently. Just kind of completely subjective and anecdotally here. I'm thinking about how much more common mobile devices are these days than they were 6 years ago, and how much more fragile they are in terms of, the available bandwidth, their likelihood of timing out on files, the expense of parsing JavaScript on those devices, and I would expect these numbers to be at least the same, potentially higher. A common counter-argument here is that these things can happen to your CSS file too, and they can. Like, your CSS file can definitely fail because of things like CDN errors and other sorts of stuff. But when CSS fails, you're typically left with an ugly but functional website. When JavaScript fails and your site depends on it, it can become completely unusable. Even when everything loads correctly, because of how browsers work, JavaScript is much worse for performance than HTML and CSS are. Adiyaz Mani wrote a really great article on why this is the case, saying, byte for byte, JavaScript is still the most expensive resource that we send to mobile phones because it can delay interactivity in large ways. If you're unfamiliar with how browsers actually work behind the scenes, JavaScript blocks the page from rendering. So when a browser hits a JavaScript file, it won't render anything else on that page. Now, CSS does this too, but that typically has less of an impact because the files are smaller, we're using less of it, it's less intense for browsers to parse and work with. JavaScript also blocks other files from downloading. So if you hit like CSS or an image or something, while it's downloading that, it has this other stream where it can pull other files. But with JavaScript, it stops all other downloads from happening because the browser is concerned that your JavaScript is going to change something on the page and it will potentially download a resource it doesn't need or do something that's going to change because of the JavaScript. And JavaScript also just takes longer to parse and render than HTML and CSS do because of the scripty nature of it. Nicholas Gallagher, formerly of Twitter Engineering, shared some data recently on Twitter's move away from their legacy codebase to a CSS and JavaScript solution, noting that the old legacy site downloaded 630 kilobytes of CSS, while the new one, which uses a progressively loaded CSS and JS solution, generates just 30 kilobytes of CSS. And the results there are really impressive. But I can't help but feel that 630 kilobytes is just an unnecessarily large amount of CSS for what the Twitter UI is. And as we'll see in a little bit, the resulting code from their PWA is effectively the same as some other purely CSS-based techniques, but with a ton of extra tooling and fragility around it. And I do actually mean fragility. So here's what happened when I switched from night mode to regular mode in Twitter a few months ago. The background switched from a dark color to a white one, but the text for the Twitter card remained white, making it unreadable. And for comparison, this is what it's supposed to look like. Now, since taking that screenshot, this has happened to me at least 2 or 3 other times. So this seems to be a pretty common recurring bug, just as a result of the way they're loading in all of their styles with JavaScript. And remember that straw man argument that Alex Russell talked about improving the developer experience? I'm actually not even sure that that's true. It probably improves the experience for some developers, specifically people who are more comfortable in JavaScript than other parts of the stack. But for people who specialize in CSS and semantic HTML, it can leave them shut out of the development process. Accessibility consultant Rian Reitwald resigned last year as WordPress accessibility team lead and documented why in a detailed article. The TLDR of it is that Gutenberg, the new WordPress editor, is built on React, and because of that, no one on her team has React experience, nor could they find volunteers in the accessibility community to help them out for free. And as a result, they just couldn't effectively work on improvements themselves. It hindered Rian's ability to do the work that she's best at. One of my students shared this React developer roadmap, and the things in yellow here are supposed to be things that are must know. The number of things that are considered must know on this page are absolutely staggering. Now, in my personal opinion, few of these things are actually things you need to know, but this kind of thing is super alienating to beginners. There's just so much in here. Like, I would see this and I'd be like, oh, I'll never be able to teach myself this. A common counter argument to kind of what I'm suggesting here is that a simpler approach may work for smaller sites, but what about big sites like Facebook? How do you manage that complexity? And to me, that's the wrong question. Making things complicated is easy. Making them simple is very hard. Rather than asking how to manage the complexity, you should be asking how to reduce it. Does your site or app need to be that big? Would it be better for the user as a set of smaller interconnected sites instead? Picking on Facebook just a little bit longer here, their portal has evolved from a simple way to share updates with friends who go to your school into this platform that supports text, photo, and video updates. They have their own TV kind of channel thing baked right in. A marketplace. I don't know if poking and throwing sheep at people is still a thing. There's a game center where you can play games. There's a chat app. There's just so many things baked into this one portal that potentially would be better for the user as a set of standalone smaller apps, all controlled by the same parent company. And it would certainly make managing the complexity of any one app a lot easier. So I've spent a lot of time complaining. Let's talk about some fixes, some things that we could potentially do differently to turn the tide here. What I really want to do is encourage you, in a way, to become a developer dinosaur. We as an industry are obsessed with shiny new things, new techniques, new tools, new trends. It's what makes this profession so exciting. Like, you never have to worry about being bored. There's always something new you can learn. But it's also what causes that feeling of not being able to keep up, of imposter syndrome, of feeling like you never really know what you're talking about, because there's always something new that you don't know. But old techniques don't become invalid just because new ones come out. often the older approaches are simpler and more reliable than the new ones. For example, bicycles are still a good transportation option even though motorcycles still exist. They're easier to maintain, they don't need gas, you don't need as much training to use one, and they can go places that motorcycles can't. The same is true for development tools and techniques. The one I always come back to is XHR versus Fetch. For me, Fetch on the surface maybe seems like it's a little bit more powerful or easier to use, but once you start doing more than just the most basic stuff with it, it becomes just as complicated as XHR, has worse backwards compatibility, so you need to use like polyfills or some sort of transpiler to make it work in older browsers, or like build in a fallback that uses XHR anyways. And XHR also has some stuff built in that Fetch doesn't. So, you can use Fetch if you're comfortable with it or it's appropriate for the project, but don't feel like just because Fetch is a thing, you can't continue to use XHR. It still works and it's great. And that doesn't mean you should never use new tools or approaches, but I want us to be more selective about what we use and why. Does it help you but hurt the user experience? Does it hurt you but help the user? Does it benefit you both? More specifically, does the utility of using the thing outweigh its cost? Lean on old and trusted approaches, but augment them with new tools and techniques when it's beneficial to you and your users. Ultimately, I want us to just write less code. So, for example, code splitting is a thing because we send too much damn code down the pipe with our sites. And you can eliminate the need for it and simplify things for yourself by writing less code in the first place. And for the rest of this talk, I'm going to be looking at some ways that we can do that. So one of them is to prefer native HTML elements and CSS features over custom JavaScript implementations. For example, for things like animations, CSS more easily hooks into the browser's refresh rate cycle to provide silky smooth animations. Now, this can be done in JavaScript too, but CSS just makes it so damn easy, and it fails gracefully. Instead of writing a custom JavaScript-based drop-down select menu, you could just use a select element. I also want us to start using what the browser gives us more. We have this tendency to break browser features with JavaScript and then recreate them again with JavaScript, which is kind of absurd, right? So native JavaScript methods and APIs can replace libraries and frameworks. Static page loads let you use the browser's native history handling and forward back buttons, so you don't have to recreate that in JavaScript. Buttons give you focusable elements and semantics, so you don't have to recreate that with CSS and JavaScript when you use spans or divs, or even in some cases links, depending on what you're trying to do. One of the big advantages of libraries and frameworks used to be that they standardize behavior across browsers, but polyfills can do that too with native JS features. And Polyfill.io from the team at Financial Times makes this super easy. You drop it in on your site, and it sends you only what you need. So on the latest version of Chrome, that's absolutely nothing. You get back an empty file. On IE8, you're getting back about 15, 16 kilobytes of minified and gzipped code, which is still half the size of jQuery or React or Vue. Progressive enhancement has fallen a bit out of favor lately. There's this line of thinking that says that people shouldn't be turning off JavaScript in their browsers, and browsers are free, so they can always just upgrade to the latest one anyways. But as we talked about earlier, most JavaScript failures are not because someone deliberately disabled it, and people don't always have a choice over what browser they use. Progressive enhancement, or building in layers, adds what Jeremy Keith calls fault tolerance or resilience to your site or app, and ensures that as much of it is as usable as possible to as many people as possible. There's this belief that progressive enhancement adds a lot of work, but it doesn't have to. For example, let's say you wanted to use the GitHub API and some JavaScript to show a list of repositories on your site. Rather than using a blank div, you can add a link to your GitHub account. Literally just view my projects on GitHub. You click it, it takes you there. Once the required JavaScript is loaded, you can use the GitHub API to get a list of repositories and replace the existing link with the data from GitHub. When that file works, you have your list of repositories, but if it fails for some reason, people can still get to those things. They still have something usable. People usually think of progressive enhancement as a JavaScript thing, but it applies to CSS too. CSS Grid makes it a lot easier to create really innovative layouts that were quite difficult in the past, but It only works in modern browsers, i.e., and older versions of Edge don't support it. But you can treat layout like a progressive enhancement. Browsers that support it get the fancy layout, while browsers that don't get a simpler single column layout. It still works, it's still functional. It doesn't even necessarily have to be ugly, it's just maybe not as pretty or as fancy. One of the goals of CSS and JavaScript is to reduce the overall size of the CSS by only loading styles that are needed for the current UI. If you style individual components, you'll often find that you end up with a lot of shared styles between different components. For example, let's say you had a callout component that had a class callout on it. And it has a background color of slate gray and a font size of 2em. There's a chance that other components in your UI might also have a background color of slate gray or a font size of 2em. In CSS and JavaScript, you might do something like this. Rather than defining those properties on a class, you create a new JavaScript object with keys for background color and font size. And then in some other HTML or CSS, JavaScript rather, that renders the markup, you put a little like variable associated with that object where the class should go. It looks pretty similar, but it uses JavaScript conventions instead of CSS ones. And that gets rendered out into something like this. You've got a div, and instead of having the callout class on it, you've got these random, tiny, obfuscated class names like JZRPS or NIBAE, LUPP. The idea is that each property gets broken up into its own class and added to the element, so you can reduce that redundancy. So where you have two components that both share the same style, they're going to get that same kind of obfuscated class name on them, rather than having those tied to a specific component. Nicholas Gallagher, the engineer who used to work at Twitter, explains that the impact on over-the-wire size of more HTML classes per element is negligible and is massively offset by the CSS byte savings. And frankly, I agree with him here. More classes in the HTML and fewer bytes of CSS shifts the file size to the part of the stack that's least affected by it. This is hands down a performance win, no question. The problem is, looking at the code that gets outputted from this, the markup, I have no idea what the hell it does. You can do the same thing without introducing the complexity or requirement of JavaScript and keep things human readable. Object-Oriented CSS, or OOCSS, was created by Nicole Sullivan quite a few years ago. If you're familiar with things like BEM, Smack CSS, Atomic CSS, Utility First CSS, they're all derivatives of Nicole's work, although she seldom gets the credit she deserves here. Object-Oriented CSS treats CSS classes like Legos for front-end developers. So looking at that same component again, instead of styling the component directly, you would create utility classes for what you're trying to accomplish. You would have a background gray class that sets just the background color, a text large class that adds 2em to the component, and then instead of having a callout class on that component, you would have class background gray, text large. This is effectively the same result as the CSS and JavaScript example, but with classes that you can read and understand. Initially, this seems like it may result in more CSS to accomplish the same thing, and for any one component, that may actually be true. But once you get a small collection of these in a project, you can start to mix and match them across components to get the look and feel that you want without adding more CSS to your code base. It also helps drive more consistency across the UI, reducing chances of each component having slight variances in things like color, typographic scale, and so on. If you've ever worked on a team or seen an app before where different pages have buttons that look kind of different from each other, like slightly different hues of blue or different border radiuses or typefaces on them, this is usually because two different teams worked on them and styled things slightly differently. And with utility classes, you can just kind of swap in and out. You get this very consistent typography and scale and behavior across the app. If this approach sounds interesting, Nicole has a really fantastic presentation on this available on SlideShare that I highly recommend. It completely changed the way that I think about CSS. Routing is something that browsers handle for you already out of the box, and then single-page JavaScript apps break it, so we add even more JavaScript to put it back in. The argument in favor of single page apps, or SPAs, is that they're a lot more performant because you avoid expensive page reloads. And there's another way to get fast page loads and remove that complexity. Static websites, that is, flat HTML files instead of dynamically rendered database-driven sites or apps, are very, very fast. When someone visits a website for a data-driven site, the server pulls content from the database, and then it figures out which templates to use and combines them into an HTML file that it then sends back to the browser. This takes time, and depending on your server, it can actually take quite a bit of time. With static HTML files, the response is nearly instant. The browser requests the file, and the server sends one back. Couple this with sending less code down the wire in the first place, and you get near instant page loads. Instead of a single page app, you can have a multi-page app. You have separate HTML files for the homepage, login, dashboard, account management. Each page renders a different part of your app, and you let the browser handle that routing for you by loading actual HTML. But because you're serving flat HTML files and you've reduced the size and complexity of your code base, it's still really fast, and I can prove it to you. I use this approach for my portal that my students use to access their course videos, and the page loads feel nearly instantaneous. This is a real screen capture of the portal, and those are full page refreshes with the entire UI being rendered in JavaScript. It feels as fast as a single page app. Honestly, the slowest part is waiting for videos from Vimeo to load, just because there's so much going on there. But you click a link and stuff shows up. It's really, really, really fast. If your site or app is just a few pages, creating static HTML files by hand isn't that difficult. But if you're managing a larger project, it would be impractical to code all of those pages by hand. Fortunately, static site generators give you the convenience of database-driven sites with simpler templating and the huge performance wins of static HTML files. Tools like Jekyll, Hugo, and Eleventy are the best kind of web tools. They make your job easier and provide a net benefit to the users of your stuff. And finally, I'd like to encourage us to just avoid more dependencies in our code. Favor vanilla JavaScript, helper functions, and small plugins over full-on frameworks and libraries. Not only is there less code to maintain, but you can more easily port your code from one project to another. You can also weather changes in your tech stack without having to refactor or replace as much. I love the experience of being able to just open a text editor and a browser and start building something. My goal is to get you closer to that experience, augmented with modern tools and approaches when it actually makes sense. I think it makes for a more enjoyable developer experience, and it results in a faster, more resilient web for your users too. So let's just quickly wrap up. To summarize, less JavaScript, more HTML and CSS. Use what the browser gives you rather than trying to recreate it with JavaScript. Embrace polyfills as a way to use native tools in a more backwards compatible fashion. Build in layers for more resilience. Use object-oriented CSS to keep the size of your style sheets down. Serve static HTML for really fast page loads, and avoid dependencies whenever you can. Not all of these approaches and techniques I talked about will apply to every project, so naturally pick and choose the ones that work best for you. And don't be afraid to become a developer dinosaur. If you enjoyed this talk and you want to get more information like this and little snippets and bits along the way, head over to gomakethings.com and sign up for my daily developer tips. I think you're really going to enjoy it. So that's the talk. I plan on creating and releasing a new version of this at some point in the near future, and I'm also trying to give this talk at conferences and things like that. So if you're interested or you want me to come deliver it at your company as part of a private event, please don't hesitate to reach out. You can find me at gomakethings.com. You can find my email and Twitter handle and all that if you want to chat about this more. Cheers.